Alright guys, today we're going to start actually graphing some polar functions. Instead of just looking at the points, we're actually going to put those points together to see what some of these different graphs we can make are. So to start, we're going to look at some of these on our calculator just so we can get through these a little quicker. So the first we're going to look at is r equals cosine of theta. So in order to graph this, the first thing I need to do is go to mode. And I need to change my mode from function over to pole for polar. So now you'll see once I have this and I go to y equals, that's going to change my y equals to r equals. So if I want the cosine of theta, I'll go ahead and type in cosine, but to get that theta, what I normally push for x now turns to theta because of the mode that I'm in. So I'm going to go ahead and graph this. And if you look, our window's a little small, a little bit too big, so we're going to need to change that. So I'm going to go to my window, and I'm going to make my x-min and x-max a little bit smaller so I can see more of this graph. So I'm going to make it from -5 to 5. Now the theta min and the theta max, we'll worry about that a little bit more when we talk about parametric equations. Okay, so now if you look, you can see it's a little bit of a small oval. Now this isn't actually an oval, it's actually a circle. The reason it looks like an oval is because we have a rectangle here. So we've taken that circle and spread it out over a rectangle. So in order to make this actually look like an oval, we're going to change our window to a square. So if we go to zoom number 5, that's going to change our window dimensions to be more like a square. And now we can see it's an actual circle. So my first graph here is going to be a circle. Now that circle, if you guys look, it had a diameter of 1. Now what I'm going to do is I'm going to go and I'm going to change the number in front to a 2. I'm going to see how that changes my graph. So instead I'm going to go back to y equals, and I'm going to change this instead to 2 cosine theta. And you can see my graph gets a little bit bigger. Alright, so let's see what happens when I change that to 3. Again, it gets bigger. The diameter is now 3. Now the last one that was on there was y equals -3 cosine theta. So we're going to see what happens when I put that negative in front. And just like it normally does for transformations, it flips my graph. So if that 2 is in front, my graph still goes to the pole, but now my graph is here. And now if the diameter is 3, my graph goes out like this. Now one thing to take note of, when the diameter is 2, it doesn't go all the way up to 2. And the reason for that is because it's my full diameter. If it went all the way up to 2, that distance up and down would actually be 4. Alright, so now we're going to see what happens when we change that to sine. So we're going to go back, and I'm going to make this y equals sine of theta. And now it's still a circle, and it's still a diameter of 1, but now it's up and down. And again, same thing's going to happen. If I make it 2, it's going to increase that diameter. Now let's go ahead and do that last one. Let's make that -3. So it's going to increase it to a diameter of 3, and the negative again flips it. So here are my different sine circles. Now there's one other kind of circle that we haven't talked about on here, and we talked about this one yesterday. If I were to graph just r equals 3, what that would do, that means no matter what angle I'm at, the radius is 3. So no matter where I go on this circle, I'm 3 away from the center. So my radius in this case is 3, and my center is at 0, 0. That's a little bit different than these graphs. Okay, but still, all of these graphs on here, these are different ways of graphing circles. Okay, so the next one we're going to look at is going to be a completely different shape. So next one on our sheet is 2 plus 2 cosine theta. Okay, so again, before we do this one actually, we're going to start graphing this one with a table so we can see why our graph is going to do what it does. Okay, so I'm going to make a normal t-chart like I always do, except instead of x and y, I'm going to use theta and r. And the theta values I choose are going to be the same theta values I use when graphing sines and cosines, because these are the easiest ones to find the sine and cosine of. So if I were to plug in 0 for theta, the cosine of 0 is 1, times 2 is 2, plus 2 is 4. So at 0 degrees, I have a radius of 4. If I plug in pi over 2, the cosine of pi over 2 is 0, 0 plus 2 is 2. So at pi over 2 degrees, I'm at 2. All right, now let's look at pi. If I take the cosine of pi, I get negative 1. Negative 1 times 2 is negative 2, plus 2 is 0. Now, no matter what angle you're at, if your radius is 0, that's going to be going through the pole. And then at 3 pi over 2, cosine of 3 pi over 2 is 0. 0 plus 2 is also 2. So there's a few points to kind of guide us in this graph, but let's see what the actual shape looks like in our calculator, because it is going to look a little bit different. So I'm going to graph 2 plus 2 cosine theta. Okay, so this graph kind of curves around and then goes back into the pole. So that graph is going to look like this. Alright, so just like, except it would actually go through those points I kind of missed. But now let's think about if I were to switch that to sine. Okay, when I switched it to sine for circles, it made it vertical. Well, it's going to do the same thing when I switch it on this graph. It becomes vertical. And it still goes through those same points. And now if I were to switch that to 2 minus 2 sine theta, just like it did before, that would flip it. Okay, so now this middle column, we're going to do these again, but then we're going to start with a chart, so we understand why our graph is going to do what it does and get some specific points on it. So again, I'm going to start with 0. If I plug in 0, the cosine of 0 is 1 times 2 is 2, plus 1 is 3. So at 0 degrees, I'm at 3. If I plug in pi over 2, cosine of pi over 2 is 0, plus 1 is 1. And if I plug in pi, this is where it gets a little bit different. The cosine of pi is negative 1, times 2 is negative 2, plus 1 is a negative 1. Now remember how to graph negative r's, I go backwards 180 degrees. So instead of graphing it over here on this side, I'm going to go backwards 1, and it's actually going to be over there. And the last point is going to be 3 pi over 2. The cosine of 3 pi over 2 is 0, and 0 plus 1 is 1. So again, to look at this shape, I'm going to see my calculator, and obviously we can tell it's going to be a little bit different already. And that's going to be 1 plus 2 cosine theta. So this graph has a little bit of a loop in it. So our graph is going to look a little bit like that. Sorry guys, these are a little hard to draw, so they're not really the best pictures, but you can see the basic shape there. If I were to switch this to sine, it would be very similar. It would go through and it would have a loop. Alright, then the last one we're going to look at, again, we're going to plot some points first. So I'm going to plot my thetas and r's and pick those same thetas I've been picking. If I plug in 0, cosine of 0 is 1 plus 2 is 3. Cosine of pi over 2 is 0 plus 2 is 2. The cosine of pi is negative 1 plus 2 is 1. And then the cosine of 3 pi over 2 is 0 plus 2. Now we're going to look at this one again on our calculator, because again this one's going to look even more different. One of the things to notice here is this one doesn't touch the pole like the other ones have. Okay, so this graph looks even more different. Okay, now to see what it's actually doing there a little bit better, I'm going to change these numbers a little bit. So let's make this 3 plus 2. There, so you can see a little bit better what that graph is doing. So what we call right there, it's called a dimple. Okay, and actually I'm going to make this 3 plus 2 so it's a little easier to see. That's going to change my numbers a little bit, but it'll be a little bit bigger. I really want you guys to see that little bit of a curve it takes right there. Kind of hard to see, but let's look at the calculator picture. It's a little easier. I'm going to zoom over on that part for you guys to see. Hopefully this will make this a little easier. Okay, so you can see how that graph comes in just a little bit. Okay, so now all these graphs that we've just done, they all have a different name. Okay, so the ones over here on the far left, the ones that look like hearts, those are called cardioids. The ones in the middle, those have a loop. And the ones on the right, those ones we call dimpled. Now, all of these together have one generic name. Okay, and I'm going to write this word here so you guys can see it. It's a little bit of a new word. Alright, and these are, I believe it's pronounced Limacon. But the way I actually pronounce them is I call them Limacons, because to me they look like lima beans, so it makes it a little bit easier to remember what this shape is. So there's 3 different kinds. Now how to figure out where these kinds, which one is which, we can look at some similarities here. When I got a heart, those numbers were the same. So if that A is equal to B, I'm going to get a cardioid. If the number in front is smaller, I'm going to get a loop. So if A is less than B, I get a loop. Then at the end, if A is greater than B, I'm going to get a dimple. Alright, now the last shape we're going to look at is a little bit different again. There's a lot of different kind of shapes we can make with our polar graphs. So we're going to do these the top 2 and the bottom left one. So we're going to graph 3 sine 3 theta, 2 cosine 5 theta, and 3 sine 3 theta, and see what those look like. So I'm going to start with 3 cosine 3 theta. And I'm going to change my window back. Whoops, I need to make this a little bit bigger. Sorry, guys. Having some trouble with my window. I want that to be negative 5 to 5. And I want my y min to be negative 5 to 5. Okay, so you can see this graph is very different. Alright, now let's look at 3 sine 3 theta. So again, it's still kind of a similar shape, it's just switched, it's just moved a little bit. And then, I can't remember what that other graph was. Let's see, that was 2 cosine 5 theta. So let's do 2 cosine 5 theta. Alright, so a couple things to notice on here. I'm going to go ahead and graph these on our paper so we can see them. So 3 cosine 3 theta, all of these look like flowers. So these are all going to be called roses. So this first rose, it had 3 petals, and they went as far out as 3. The sine one also had 3 petals that were a length of 3. It just looked a little bit different because of where they were located. So cosine, usually horizontal stuff like we've been talking about, has one of its leaves on that horizontal axis. The sine has one of the ones on the vertical axis. In order to figure out exactly where those are, you can always plug in some of those normal theta values to figure it out. Then the 2 cosine 5 theta, that one had 5 petals, and each one was a distance of 2. Now if we were to graph the sine one, we would still get 5 petals, and we would just have one of them that would be vertical. So you guys can see that number on the inside is the number of petals. And the number on the outside is the length of each. So this last one here, without drawing on the calculator, we can see what it's going to look like. There's going to be 7 petals, and each one is going to be a length of 4. And they should all be the same length. Those obviously do not look like they are. But you guys get the idea. You can see a much better picture on your calculator. Alright, and the last section we're going to look at, these look like the same kinds of equations, but there is going to be a slight difference to them. So let's graph 3 cosine 2 theta and 3 sine 2 theta. Now you'd expect these would be roses with 2 petals and each with a length of 3. But what's going to happen here is instead we have 4 petals. And if I change it to sine, there's still 4 petals. They're just not on the axes. So what's happening with these is the 3 is still the length. The only difference is when that number is even like this, there's actually twice as many as you'd expect. So if that number is an even number, then there are twice as many. So in this case there'd be 8, and because it's cosine, one of those is going to be on the line. So we can go ahead and draw the ones that we know are on the line, and then because there's 8, there's going to be some in between. Alright, so these are just some of your basic polar graphs. Now one thing that your book has that can make these a little bit easier to draw is it gives you kind of a guide for some of the different ones we've looked at. Okay, where A and B are just 2 different variables on there. Now the only thing to be careful about this chart is it doesn't have everything, because for example all these Limacons that we have here, the ones that are shown, those are only the sine ones, because we know the cosine ones would be horizontal. Right, we also know those are only the sign with a plus. If it was minus, they'd be flipped. So that's just one thing to keep in mind. But this is a good little reference for you guys in your textbook if you guys need some help drawing these graphs.